Okay, welcome back, ladies and gentlemen. Today's kind of unusual because we're starting a new unit, but we haven't ended the other one. And I did do some review with you yesterday, and I'll do a little bit of review at the end of this. But Monday is planned for a full day of review, and then the test will be after that. Okay, so we're starting into the new chapter here a little early. So this is called Identifying Polynomials. So just a quick reminder, yes, the lab is still out there. And on a 35-minute day where I'm trying to teach old and new, that's not going to happen. But we'll get to it eventually. All right, so take a look at this. Is that a polynomial? Well, here's how you can tell. On a polynomial, it has to have certain things. Like just having a lot of terms, poly means many. So I know a lot of you are like, oh yeah, it's got many terms, therefore it's a polynomial. Nope. There's rules for what makes it a polynomial or not. And one of the things that you're looking for is that the powers that it has, they should be lined up in order from biggest to smallest. Okay, so this one doesn't have the lead term first. You get how that one's more important than the others. Why? Because you remember that whole like negative in front makes the function flip? Well, what's the front? If you move this guy to the second spot, then it's supposed to be the one that's in the front. You can't tell whether the thing has had a vertical reflection or not. Okay, so you need to know which one's got the biggest power. That makes this the lead coefficient, and the lead coefficient's a big deal. Okay, so that's one thing you need to know about polynomials. All right, is there a constant term? The word constant just means it doesn't have a variable, and it's just a number, like 2. And so, yeah, this has a constant. Does this have a constant? Yes. Now, to decide whether or not something's really a polynomial, you're just going to be really looking closely at the powers. All right, so are these both polynomials? Yeah, those are both polynomials. All right, let's move on. Are these all polynomials? They are. So what would not be a polynomial? Something that would not be a polynomial would have a fraction or a negative exponent in it. Okay, so if I said y equals 2x to the negative third, not a polynomial. Wouldn't that be the same thing as y equals 2 over x to the third? Yeah, it would. And you can't have your variables down in the denominator of a fraction, or it's not a polynomial. All right, so all this slide is really asking us to do is identify the degree, the leading term, the leading coefficient, and constant. So let's do that, but here's a question first. Yes, sir?
So wouldn't a square root also make it not a polynomial?
Yes, any strange powers. So for instance, I gave you the example of a negative. Here's another one, 2x to the 0.5 power. Yep, any fraction power, I think is the word I use. But a square root is a fraction power, right? So you can't have fraction powers, can't have negative powers. And yeah, let's talk about the actual answers to the questions. They are asking us, what is the degree of this first one? The degree is 5. Some people think you add up all the powers. You do not. Write these down. Tying a small knot is not going to be as good in the long run. All right, the next one is the leading term. The leading coefficient, I'm going to call that. Oh, wait, the leading term, my bad. The leading term, I'm just going to circle, is the one with the biggest power. There, that one's the leading term. Happens to also be in the front. The leading coefficient, in this case, is the 4. It's the number in front of the leading term. And then constant term. People constantly ask me what the constant is, and I tell them the same thing every time. Get it? Get it? Constant stays the same all the time? Okay, anyway, so in this case, it's negative 5. Okay, so let's move on. I think you got this stuff so far. The classic box problem. I need to go through this with you for the first time, but it won't be the last time because this really gets at why you'd ever have something like x to the third plus 4x plus, or 4x squared plus x plus 7 in the real world. It's a good example one where you're going to end up with a polynomial when it's done, and it's all about making a box. So it's a good real world example. Let's zoom in on this box. Now, the idea is you have a piece of cardboard, and do you get if to cut the corners out of a piece of cardboard, you could glue, fold on the dotted lines there and glue the sides up, and you'd have the bottom part of a box. Does that make sense to you? Okay. I know, in the real world, complications. In the real world, you'd probably leave little tabs like this so that you could not have to have just glue holding the seam together. You'd want tabs there and stuff. We're not going to make it that complicated because it really would add a lot of complication. So we're just going to simply cut the corner out, and you'll be left with a template that you can fold up and make a box. All right, so how long is this side? 10 inches. But after you fold it up, it won't be 10 inches. But you need to tell us how long this is. No, I don't. So what if I don't tell you how long that is? Well, then it's 10 minus h. No, it's not. Who can fix that? The side, I told you I don't know what h is. Because h is a variable, as in you can change how much you cut out, right? So I said 10 minus h, or, I keep saying h's. It's because I had my iPad sideways. I think these are x's, aren't they?
Yeah.
Okay, sorry. I was looking at it backwards, sorry. Those are x's. So this is not 10 minus x, but it's close to 10 minus x. Help me out. What is it? 10 minus 2x. Think about it. Wouldn't you be subtracting from the length from both sides? So it wouldn't be 10. It wouldn't be 10 minus x. It would be 10 minus 2x. All right. So use that same logic to tell me the other side. It's not 12. It's not 12 minus x. It's 12 minus 2x. What if I wanted to figure out the volume of the box when it's all folded up? My strong recommendation is whenever you write out a formula, you write out the whole formula. I was trying to correct you guys when you would say just negative b over 2a, like for instance, and I would say no, x equals negative b over 2a. Why? Because you need to have both sides of the equal sign there. And that's going to happen again this time. So what is the formula for volume? V equals, why do you need the v there? Because sometimes they tell you the volume, and you need to know where to put it. Okay, so v equals, and who knows the general form for volume of a box? LWH. Okay. Always start with the pure form of the formula. Now, stick in everything we know. Now, if they had told us how much the volume was, we'd put it in here, but they did not. Did they tell us something about the length? Yeah, so we don't just put L, we put in the length in terms of X. Now, I have a general rule for you. The longer side we're going to call the length because that has an L in it, okay? I know you could argue how this one should be the length because of how it's arranged. It really isn't going to hurt you if you do it differently, but if you want to try to follow the keys and stuff, the long way is the length. So what should I put for the length? 12 minus 2x. What should I put for the width? 10 minus 2x. What should I put for the height? A lot of kids have trouble seeing this. Once it's folded up, how high will the box go? X. Very good. So, guess why we're talking about this in the polynomials unit, because when you multiply that all out, you get a polynomial, and it's to the third. Instead of in the past, you typically would have things that are a quadratic and therefore squared. I want to remind you what they kind of look like. If I graphed this, finish the sentence for me. The y-intercept would be where x equals 0. Could I put in a 0? Well, it would be 0. Does that mean that the y-intercept is somehow wrong? No, the y-intercept is 0. Okay, so y-intercept is where x is 0. I stick in an x right there, even just there, whole thing's going to be 0. Okay, now if I graphed it, can you imagine it might look something like that? Because x to the thirds can do that. Okay, can you also imagine that it could, you've seen another x to the third in your past. Is that such a possible thing too? Okay. And if I don't limit my domain on this, I'm going to be able to say, yeah, you can cut out a 12-inch corner out of the box, but in the real world, can you actually cut a 12-inch corner out of this box? No, you'd have just destroyed an entire side. It wouldn't even have sides anymore, and so no way you can cut out 12 inches. So the domain becomes important. So the domain is like from here to here. Well, what's there to there? Well, I got to figure that out by looking at my picture. Now I'm going to look at the box problem a little closer and say, what's the biggest that X could be? I know we could have a really small corner if we want. That's doable. But as the box corners get bigger and bigger, eventually we're going to be constrained that we can't just have any size we want. Who knows the biggest that X could be without destroying our box? What do you think?
6.
You think it could be as big as 6? Let's find out. If I put a 6 here, and a 6 here, and a 6 here, and a 6 here, is that even feasible with this being 10? Now, you were thinking about one of the sides would be okay with that, but not both. You see what I'm saying? So it really helps to draw it out for yourself. Picture's worth 1,000 words. When you see that, you go, no. That's cutting out 12 inches out of a side that's only 10 inches. Yes?
4.
Okay. And why didn't you say 5?
Because it would ruin the side of 10 inches.
Yeah, if we used 5 for everything, I know you know that 5 won't work. But what I'm trying to get at is, you went with 4, which definitely would work, but isn't there some gray area in between 4 and 5?
Yeah.
Maybe it could be a little more than 4, but it can't be 5. See what I'm saying? What do you have to say, sir?
Could we say like infinitely close to 5?
So how would you say infinitely close to 5? X, which is how long our corner is, needs to be less than 5. Now I know there would be some practical, real-world constraints, like, yeah, you really want to have a box that has a 1/16 of an inch, like, well, I don't know, there are such a thing as, like, slots to, like, slip in a CD or something, so, there could be, reason to have a super thin box. Maybe it only has to hold a knife, you know what I mean? And it could be super narrow. But it can go up to 5, and then here's the problem. You get it marked wrong because I say, nope, your domain's wrong. You didn't include another real-world constraint. 0. Can you make your box if you have a X of 0? No, you have a flat piece of cardboard, right? So you have to say that the X has to be bigger than 0, but less than 5. Does that make sense? Is there any part of that you're like, don't get why it can't be this? Now, do you get why I would have this answer all the time on the test? X is between 0 and 6. Because kids looking at that one other side that's bigger, and they're saying, well, you can cut up to 6 on this side. Yeah, but it has to go in both edges. So you can't go based on the bigger side. You have to go based on the smaller side. So watch out for that. Okay, next thing. What if they had told us the volume they needed? Is that a very realistic possibility? Yeah, because I actually am thinking about ordering some custom boxes, okay, because I mail stuff out to people sometimes for one of my businesses, and I need to be able to tell them how big the box needs to be able to fit my stuff, okay? So I'm going to probably be not using the actual words volume. I'll probably, in the real world, be saying it needs to be at least 8 inches wide and at least 11 inches long, you know what I mean? To fit a piece of paper, it'd be 8.5 by 11, right? So I'd probably say I want it to be at least 9 inches by at least 12 inches so that I got a little bit of room around the thing that I want to put in there. So you might have some real world constraints where you would ask for certain side lengths. But volume, if you were trying to fill it with something, like for instance, I don't know, the thing that you ship across the country is like sand. Yes, there are people that actually sell sand. And I guess for some people it's like, this is real sand from Fort Myers Beach. And I love Fort Myers Beach, and so I bought sand from Fort Myers Beach. There's other people who sell sand that's mixed with a little bit of wax. Have you ever seen that before? It's kind of cool. It's kind of like Play-Doh in a way. It's sand like at a beach, except a little bit of wax in there means that you can form it And it's actually really cool stuff. So anyway, you might decide to give your person a volume constraint of it needs to hold at least 1,000 cubic centimeters. Then that has to go into your volume. And then you'd have this equation right here of 1,000 equals all that, and it has only one variable in it now. What's magical about only having one variable? You can solve it. You can solve it for x. And these are typically going to be solved with a graphing calculator, because these are really difficult to do by just like factoring and trying to find the zeros and trying to test intervals. It could theoretically be done. But we'd have to set up the problems to have super nice numbers so that they would happen to factor, and you might have even forgotten how you would ever factor something like that. Just a quick sidebar. Do you remember factor by grouping? Factor the first part. Factor the second part. Uh-oh. Didn't make a factor. I'm going to cheat a little bit, make that an 18. And now it works. Look at that. I got an x plus 3 in both of them, so I can factor out the x plus 3, and it's x squared plus 6. All right, so you can factor things that have to the third power if you remember how to, and I screwed up my problem again, change that to an 18 if you actually want to try this at home. But we could have found the zeros and then tested little intervals. That would be more like the test that you're going to take on Tuesday. Would have been not this complicated, but you'd find the zeros and then you'd test around them. Now, in the real world, could my x be -3? Remember what x was. It was how much we're cutting out of the edge of the box. Can you cut out a length of -3? No. So that's out. All right, and then, anyway, we're going to stop here because I'm taking it to where you're going to eventually go, but you don't have to be there yet. All right. You've seen the box problem, though, and that's a big one for your future. Okay, some reminders about the end behavior of functions. I think I'll be able to get this across to you faster by just reminding you this way. Do you remember in higher algebra where we'd be able to say, oh, that one's an odd one? Because its ends are going in opposite directions? That ring a bell? So that must be like x to the third, or x to the 5th, or x to the 7th. It has to be odd, though. And it can't be x to the 1. Why not? Because it'd be a straight line. Okay, so it'd be x to the 3rd, x to the 5th, x to the 7th. All right, and then do you remember back from higher algebra when it has both ends going up or both ends going down? That's got to be an even one. And I know it's not x squared because I know that was a parabola, right? So it must be x to the, but you don't know for sure. You can't just like count these up and go, oh, I think it's going to be for sure x to the 4th. You don't know that. It could be x to the 4th, 6th, 8th, 10th, etc. I just know it's not x squared because that's not how parabolas look, right? But it could be 4th, 6th, 8th, 10th. And you can't tell because there's a lot of imaginary roots that you can't see. All right, so who remembers this part, though? I know it's odd, but my question is the lead coefficient positive or negative? Could this possibly be the answer? Well, the +8 leads me to believe it could be right. Could this be right? No. Why do you think not? You seem to be shaking your head confidently.
Me?
Yeah, you.
Oh.
Nope, sorry. I'm sorry.
Sorry.
I'm pointing directly over your head at a girl who was answering the questions. Go ahead. DH.
So I don't think it's negative.
I agree. It's not negative in front. Why not?
Because if it was negative on the left side, like the left arrow would be going up on the right side.
All right. I'm going to just say you're right on one of those two counts. If the right side is going up, it has to be positive. Okay? That's all you know for sure about this lead coefficient. That just tells you the right side. So since this end's going up, that has to be a positive lead coefficient. Now you're right because of also including this power of 3, then you're right. Since this end goes down, the other end would have to go up, but that's answering more than what we needed. So if I give you just this, you should be able to tell me two things. The y-intercept is where x is 0, so what's the y-intercept? 7. And what is the right side of the graph doing? It's going down because of that. This is something you learned in higher algebra, and I'm not meant to give you the full explanation now because it's supposed to be a review. So this tells you the right side down, and this is our constant, and so if x was 0, which is where the y-intercept would be, then this is the y-intercept. And last but not least, if it's got a power that's odd, you know that both ends have to be going the opposite way. So could what I just drew here possibly be the right answer? No, it's wrong in like 6 ways. Tell me one way it's wrong. How about the right side? Is the right side going down? The right side is going down, so that part's okay. What else is wrong? Both ends are going down, which means that this should have been a what? Even, and that this isn't even, this is odd, so that can't be right. What else is wrong about this? The y-intercept. The y-intercept is supposed to be 7, it's at negative something. Okay, so I could seal this one wrong in like 3 different ways. All right, one more like that. There. Could this possibly be the right graph? All right. It could be the right answer except for one thing, and I'm going to change this now just to show you. Some of you are thinking no, but for the wrong reason. I'm going to change my original to have a plus here, and now I will say that is a possible right graph. If I just make this a positive 4 at the end, that is possibly the right graph for this. Roughly sketched, granted, but why? Well, because I tried to trick you with the whole lead. How many of you guys noticed that that's actually the lead? If you didn't notice that, that would have got you. Okay, so this is a positive one, so it's going up. It's even, so both ends are up. And the y-intercept's 4, positive, now that I fixed it. And yeah, this could be it. Okay, cool. You've learned or reminded yourself about a whole bunch of things for the next test that we have. But let's worry about the test that's coming up in a few days. I'm going to give you one to work on as your homework for tonight. So let's go. I'm going to assign that. Then I'm going to just do... we're going to do some review after I show you what the homework is. Okay? The homework is from assignment day 1. We're going to do problem 2. And I like this one because it's all factored out and make you think. So problem 2, problem 7. This is just reminding you how to move it to the right 2 and up 1. You start with an x to the 3rd. So I think you should do 21. It'll remind you about stretching and shrinking and shifting to the left, shifting up. And this is kind of like saying, hey, start with this and then do this. Okay, and that you do all of it. I'm trying to give you a nice, easy weekend. Okay, now, we're going to take a minute to do some more review problems for the test. Act like today's the test. We're not done yet, are we? Remind me when we're out of here. 33? Okay. I'm not going to go all the way to the end, but I'm going to give you 5 minutes of review at least. Okay, so act like it's a test, and this was the question. What if y equals -6? Who's got the answer already? What do you think you see?
It won't work.
What do you mean won't work? How dare you? But if I add 4 to both sides, still doesn't work. -2, this is what you got to get to though. Get it to be just an absolute value. And look at that. Can an absolute value ever be negative? No solution. Now some of you probably got that far and then started splitting it up dutifully into 2 answers, and then you'd have got 2 answers and they'd have been wrong. So watch out for that. How could you have caught it? You could have waited till you got the 2 answers and gone back and stuck them in and then went, wait a minute, neither one of these works. Okay, so double check yourself. All right, how about if I do one of these? Solve. Pause for a minute and give that a try. Okay, let's see if you're thinking the same way I was. Well, I could write 2 equations, x squared plus 3 equals 2, and x squared plus 3 equals -2. Subtract 3, subtract 3, subtract 3, subtract 3. X squared equals -1. Ooh, that's weird. Can you square something and have it equal -1? How about on the other side? X squared equals -5. Whoa. Okay, now, how could I have known that was going to happen? If you graphed it. Okay. If I had graphed this, you'd notice that the parabola was shifted up 3, but then the line y equals 2 ran underneath it like this. Do you get how you can tell they don't touch? And you wouldn't have been fooled into getting 2 answers. So remember my advice, sketch them, get a quick sketch, and you'll know how many answers you're looking for. Sometimes you don't even have any answers. This one, the U shape and the straight line y equals 2 would never have touched. All right. And that is a very shrimpy assignment. I strongly recommend more. Let's try this one. I has actual answers, I promise. You know what would be really nice though? Let's change that to a 6. Make it a 6 on the right side. You'll thank me later. Pain to change it now, but it'll make it a lot easier to work with. Now, we're running up near the end of the hour, and I want to just mention, you may note that I didn't assign you any new problems to do to prepare for the test. I'm only giving you new problems from the new section about polynomials. So if you wanted to start your review process over the weekend, what you'd do is go back and find problems I had you skip on past assignments and do some of those. It would be advisable. Not saying you have to. Many of you guys have A's, and you're probably going to get A's again because you're just really good at this. I'm more talking to the kids who got B's and are like, dang it, why do I have a B in here? I want more A's. Well, then, if you need to get your grade up, you start doing differing things. You know, like you try more. One of the things you could do is if you've got a B going in here and you'd like an A, that's the kind of thing you do. Do some extra review problems this weekend. Go back, revisit assignments we've had, problems we've skipped. That'd be smart. Okay, let me finish this question, but do you have a question first?
No, you could.
Okay, thank you. All right, so I'm going to finish this up quick. Splits up into 3x plus 6 is less than 6. And then 3x plus 6 is greater than negative 6. And if you caught that, I switched the sign when I made that negative. Now I'm going to subtract 6, 3x less than 0, x less than 0. I can divide by 3 to show you what I did there, but okay. Minus 6, 3x greater than negative 12, divide by 3, divide by 3, x greater than negative 4. Put them on a number line, you'll see really what's going on. Here's negative 4. Here's 0. It's bigger than 0. It's less than negative 4. There's my answer. 12-minute warning, but that's the wrong day, so it's less than 12 minutes left. Okay, I'm getting dissent that this may, oh, wait a minute. Dang, you're right. I just shaded the wrong ways, didn't I? X is bigger than negative 4, should have been to the right. So, my bad. Thank you for catching that. I don't think I can even blame my alarm because I think I made the mistake before the alarm went off. But I was about to check if I was right. I'm serious. Well, how was I going to check? I always test an interval. So I'm going to test an interval now, and I'm going to test a number that's in here, so like negative 2. How do I tell if I'm right? I'm going to go put a negative 2 right in here and see if it's really true. And it turns into 0. Is 0 less than 6? Yes, it is. So I would have tested that and gone, uh-oh. Would you have checked? I hope you would have. Check intervals to make sure you do them right. Because it is the most common mistake is to shade the wrong place. And there, I just demonstrated it for you. Not on purpose, to be honest. But, yeah, you can see it's easy to goof up your shading. All right, so then your final answer would have been negative 4 to 0. And I'm just going to double check one more thing. Should they be parentheses or brackets? Well, I didn't ever say or equal to. So then those are empties, not filled in circles. And therefore, it is parentheses. Okay, that's a good review, and you've got homework to do, and I kept it smallish. You keep doing your job and getting it done. And that's all I got for you for today. See if they have a box problem for us to try. Then I'm good with that being it. Nope.